Welcome to the Peggy Smedley Show. We are coming to you live here from the Microsoft build, and I am joined today by Galen Hunt. Galen, welcome.
Thank you, Peggy. It's great to be here.
Galen, I am so excited. You are a distinguished engineer, and you've been working on a wonderful product. You've got products for us, and I love props because everybody loves that. So tell us a little bit about you and how long you've been doing this with IoT and Sphere and all these crazy things, because you started right at the beginning, and now you've got lots more people with you.
Yeah, so I started this project about 4 years ago.
How exciting.
In Microsoft Research, okay? So we have this unique environment at Microsoft Research where we hire people who are subject matter experts, PhDs, and basically just say, hey, here's your paycheck, go find interesting problems and figure out how to solve them. And
love the innovators, love the innovators.
Yeah, love the innovators. And 4 years ago, somebody came into my office with something that looked like this. It's a microcontroller, it's a single chip computer, and said, hey, this is the very first chip that's going to have a full computer and Wi-Fi on it. Could we turn these into IoT devices? And what would we want for an operating system if we were going to do that?
And we talk about the importance of IoT devices and chips because we're talking about it, and you guys talked about it today in the opening discussion about security and the importance of that, right?
Yes. Yeah, so and this is in fact the thing that was really my interest. So I've been at Microsoft 20 plus years. And
so you're not a new kid.
I am not a new kid. No. I've got a nice bald spot, things like that. I've been doing this a really long time, figuring out how to build things that are connected to the internet and do it securely. And the unique thing about these microcontrollers is they're just a single chip that's much, much smaller than a traditional computer. And so the fundamental problem we had to figure out was how do we take these chips that are very, very primitive, very small computers, and bring the kind of security that you need to have in an IoT environment to these chips.
And that's been a challenge because the chips have gotten smaller and smaller, and that's how we've been able to get them in more and more devices, right? And they've gotten cheaper, the costs have gone down, the accessibility into the types of devices is what's made it unique, right?
Yeah, these chips they're just a couple of, $1, $2, $3, $4.
That's been a big difference from what it used to be.
And they're, and they're in absolutely everything. So there's about 9 billion MCU-powered devices ship every year. Okay, 9 billion.
That's crazy, right?
It's like 6 times the number of phones. It's more than all the humans on the planet every year in these new devices. And we're at this moment of opportunity, I call it, because none of these devices, basically none of them are yet IoT devices. Okay, so they're things like your kids' toys and your home appliances. Your refrigerator's got an MCU in it.
Isn't that crazy? So our refrigerators are going to talk to us. It's going to be connected to everything.
They're going to become connected, and they're all, yes.
And they're going to tell us what we should or shouldn't eat, right? They're going to count our calories.
I don't know about that.
They're going to tell you you've been drinking too many beers. Wife's going to know that soon too, right?
Well, she probably can figure that out already, right? Well, the important thing it's going to do is it's going to do things like, I used to like to use the example of how do you know the compressor in your refrigerator has gone bad? Okay, today, because you go home and you got...
foods are spoiled, right?
Yeah, you got spoiled milk and melted ice cream, okay? Now, in a connected world, if that fridge, instead of just having a standalone microcontroller, if it had a connected microcontroller with a little bit of ambient intelligence, because you get a message from the fridge manufacturer saying, hey, Peggy, you may have noticed your fridge has been making kind of a funny noise. That's because the compressor is worn out. We're going to have somebody in your neighborhood tonight. Can we stop by and replace that compressor so you don't lose any of your food?
So 2 things are what you're talking about here. Not only are you saving all your food, your meats, the cost of that, but now you have the service side of that. Someone's going to come out and tell you and come out and service that before that. And the connectivity behind that is what's amazing.
Yeah, and it creates this, for the first time, a direct relationship between you, the consumer, and the company that manufactures that device.
And we've never had that relationship with our manufacturers because in the past we've purchased something and that's it. It's over. There is no relationship with our manufacturers.
That's right. So you think about, okay, so this fridge can tell you when it needs repairs. Okay, in fact, tell the manufacturer so they have the right person and the right part. It can tell you, for example, if say you've got a water filter in it. Well, the manufacturer can send you a water filter whenever you need the new water filter.
Because we have that all the time. You get this little light on and you're always wondering, what the heck is that light for?
What do I do about it? Exactly right. Translating that, something they're known about the device in action. If you move into other things like a dishwasher, it could order your dishwashing, store it for you automatically. Another example I like to use in the kitchen is like imagine the stove telling the dishwasher, hey, they burnt the lasagna, you better turn on the heavy scrub for the next load.
How amazing. So what we're talking about is our homes are going to be connected in ways we've never really imagined right now. So those things that are happening, you break a shelf in your refrigerator, how it's going to replace it, your stove, how you're going to wash it, or now even times now when to turn on your appliances to conserve water. So these things are all going to happen based on what's happening in our environment, the sustainability. You're talking about things that we as consumers don't really know right now, but we're talking about so much more than what we've ever imagined. And it's all starting from a microcontroller.
Yeah, and it's going to happen in factories and offices and farms and mines and lots of other places too. I just like to use the home appliance ones because all of us can relate it immediately to that
But we as the consumer are truly going to impact that because we don't realize it when it's in a factory because we're removed from it. But when we think about it in our homes, there's so many things in our homes that are going to be influenced by that. And that's what you're describing here today, right?
Yeah, that's exactly right. Now, let's talk about security, okay?
Because that's a big one.
It's huge, and it's terribly important for these devices because if you think about your devices in your home, in your kitchen, those are not benign devices. I mean, they are now, okay, but you can think about things that could go wrong with those, okay? I'll give you an example. The difference between a bomb and a gas stove is the programming on
now
your gas stove. Now
you just freaked us out, right? Someone's just thinking right now, we get nervous about someone hacking our car, but now you just open that thought process of someone hacking your home and starting a fire, blowing up that stove. Same concept, right?
Yeah, or using your dishwasher to flood your house. Okay, or your fridge.
Now nobody wants their appliances connected.
Or your
Gavin,
fridge.
You just said all that, right,
your fridge to make you sick. Okay,
it's crazy.
So it is crazy. It's absolutely crazy. And the difference is opposite. We want to. So you think about this world, this connected world, and then you think about these possibilities of the negative side of that. Well, we don't want to live in that world. Okay, we don't want to live in that insecure world, right? And I don't want to live in that. Okay.
Yeah.
And the great thing is, guess what? I have something I can do about it. Okay, so 4 years ago, we started to see that these MCUs that are in all these devices, we're going to start adding radios and start having the ability to become connected. And I saw, oh my gosh, look at all the things that could go wrong, but also look at all the positive things that could happen. How do we make sure it's the positive side and not the negative side? Well, that's when we started this project. At the time, it was codenamed 4x4. It's what we've released as Azure Sphere. And what we basically said, Microsoft, we've been fighting what I call the internet security battle for 20 years. In other words, once you take a device and you connect to the internet, you do two things. One, you enable all sorts of new wonderful powerful scenarios. But the other one is you created a two-way street, which means people can come in and attack that device, and it becomes a battlefront. And the fundamental question we started with is, how could we bring the very best of what we know about security to these MCU devices? Okay, and then you think about the manufacturers that are building these MCU-based devices, a fridge manufacturer, a dishwasher manufacturer, or I often talk, example, use the HVAC, so your heating or cooling system in your house. I had a conversation back in January with a guy who is the chief security officer at a company that builds HVAC systems, and he says, Galen, you have to understand, we just basically know how to bend sheet metal. That's what we know how to do. We don't know how to build these highly secure devices, and so we need your help. And that's what we've done with Azure Sphere. We've created this solution that allows any manufacturer to build a device that is highly secured.
When we think about that, because now we're always chasing the bad guys because they're trying to circumvent all of these things. And that's what we've talked about. We've been nervous about connecting our home systems, connecting our personal devices. So now what you're saying is we're trying to stop the bad guys, or at least our fear of the bad guys from getting into these. And is that what you're saying here, is that now we've got an extra defense when we talk about connecting our home systems, whatever they might be, and that's what Azure Sphere is doing?
Yeah, and in fact, we're saying even maybe something a little bit stronger, which is we actually can take everything we've learned in the PC space about how to make PCs secure, and we can can bring it down to these devices and actually really advance, even bring possibly even better security than what we've seen on PCs, because we're kind of starting from a ground zero where we don't have anything that we don't have a legacy that we have to deal with. We can immediately say, okay, what do we know about the very best principles about how to build secure systems, and can we bring them to these devices?
We've heard up to this point, people hacking cars, as I mentioned earlier, hacking baby monitors. Is this going to prevent that? If what we've talked about is we connect these 20 billion devices, is this going to be the way that we're going to kind of prevent some of that from happening? I mean, we all know that the bad guys are always out there. Yep. We always know that, but this is a way that's going to say, look, we've got all these devices, they're all going to be connected to the web. There's always some challenge. Is this one of the ways that we're saying that we hope that we're going to stop that?
We think we're going to fundamentally make the world much, much safer than it's been before. Okay.
And so we can then, what you're saying is, don't have that fear anymore. Go and connect your devices. Be able to connect your home to Cortana. Be able to talk to Alexa, whatever that might be, and be able to do those things you wanted to do.
As long as it's a device, and here's what we talk about. We talk about a thing we call the 7 properties of a highly secured device. We actually have a paper that we've released a year ago, aka.ms/7 properties. Okay, and there's 7 properties that, if as the manufacturer, they can create a device that has these 7 properties, they will have a device that is highly secured. I'll rattle off the 7.
Yeah, let's hear those.
Okay, it's okay. So we talk about a hardware-rooted trust. So this is a fundamental capability in the physical chips that allows them to have a strong identity that's cryptographically protected, and protection of the integrity of the software running on the device. Okay, and then there's 3 properties that go above that. There's a small trusted computing base. So and defense in depth. And defense in depth is the idea of it's like a castle. You know how in a castle you have multiple layers of keeps inside each other. Okay?
Building on top of it.
And this is critical because when we talk about, I hesitated when you said, does this mean we're not going to be able to be attacked? We know we'll get attacked. Okay, and in fact, what experience has taught us is that any given device, if someone really, really, really wants to attack that device, they're going to attack it, and they will find some way eventually to get at least partially into it. And the critical thing is to build the device so that you've got multiple layers of defense and depth. So that if someone's able to breach one layer of security, you can actually detect and say, look, someone's just broke in. Let's stop them before they are able to go any farther. And actually, we'll collect enough information that we can prevent them from getting into any other device as well. So this is one of the properties we talk about. It's renewable security. It's the ability to actually improve the security on the device.
So as they're trying to infiltrate, you can actually see what they're trying to do at some point.
Yes.
And that's that assurance that consumers will have from this.
And so, in fact, we use the word, we don't talk about a highly secure device. We talk about a highly secured, and that's because we recognize that the security has to keep evolving over time on these devices. And a key thing of the Azure Sphere solution we've come up with is the ability to be able to actually improve the security continuously while this device is out in the field.
So as you look at all of these things and you're looking at the 7 principles that you have now, how well has that now come up with developers and companies that are partners to Microsoft that say, we want to be a part of this. We want to be a part of the community that works to bring more products to market?
Well, we found the 7 properties.
Properties.
And I'll tell you why. We use the word property because it's measurable.
Less principles, properties.
It's something you can actually go look at and you can measure. Okay, but what we found is these 7 properties have given the community, the IT and the IoT community, a vocabulary now to talk about security and be able to look at a proposed solution. In fact, we find manufacturers now handing this paper out to their developers, say, whatever you're building, go look and evaluate how secure is it, and you've got a metric. How many of those properties does it have, and how good does it have those properties? So we found great traction with that, and it's not even technology in a sense. It's this paper and a framework to help people talk about what the security of the device is. And then, so that brings us to Azure Sphere. Okay, so the solution, right? So what we did with Azure Sphere is we said, look, these 7 properties, they're like almost impossible impossibly hard to do on any device. And so we're going to take everything we know about how to build security and give you a solution that lets you actually, before you even start, you've already got all 7 properties. There's 3 pieces of the Azure Sphere solution. The first one is a new class of microchips, an entirely new class of chips. In fact, that's what the prop is that I've got here. I actually have a whole tray. It's the very first production Azure Sphere certified MCUs. Okay. These happen to come from a company called MediaTek. We have at least over a dozen other companies that have signed up. We're going to produce their own MCUs that are these Azure Sphere certified chips. And each of these chips has Microsoft's has been working on building secured devices for a really long time. A key example of this is our Xbox consoles. Okay, and there's a place where we really care about security because it matters to our partners in the ecosystem to protect their content, for example. It matters to our customers to protect their privacy. They have these devices in their homes. They care about them. And so over 15 years, we've built what is really probably the best security system, some of the best security around. And we figured out how to take the learnings from that and put it into every single one of these chips.
When you look at that and you put it into each of the chips and you focus on that, what are the biggest hurdles you found that you've had to do? Because I assume right now it's not been easy. I mean, you find some things, you think you're making a success, but you've got some hurdles you've had to overcome.
The biggest challenge is these are little teeny chips. Okay, you have to take, obviously, like one of these chips is a couple of dollars of electronics. I contrast that with the Xbox 3 or the Xbox One. It's like, I don't know how much, but it's like hundreds of dollars of electronics. And he's like, okay, how can you take the same kind of what you learned about security there and shrink it down to this very, very low cost point? And that was actually the absolute biggest hurdle. It's figuring out how to shrink this thing down. And we had to figure out how to create a new IP block. That's the term they use in the silicon community. The software analogy is a library.
Right.
Okay, a library that I take and I put it to combine with my parts to create a new chip. Well, we had to create a brand new IP block, brand new silicon library that these companies could use. We also had to figure out an architecture, how to put the pieces of the chip together so that the chip didn't just have this secure hardware root of trust, which is that IP block we talked about, but also had multiple layers of defense and depth in the chip itself. And that was significantly challenging. Okay, and then go out and work with the silicon manufacturers, these people that build these MCU chips, and teach them how to do this and how to use those pieces and bring them together. Okay.
Going forward, is it going to be also you have to find IoT gateway partners and all of these others to kind of continue on with what you're doing with that?
Well, so there's the chips, and then the other 2 pieces of the platform are an operating system that runs on these. Okay, because one of the things we know is it doesn't matter, whatever silicon you have can be as secure as you want, and then what really security depends on what you do with the software. And so we built a multi-layer defense and depth operating system that runs on these chips. And one of the things we did there, by the way, is we've used a custom Linux kernel as part of that for the very first time on an MCU class chip. So we had to build an operating system. And then there's a cloud service that goes with it, the Azure Sphere security service. And it reaches out and keeps all of the chips secure. It provides updates and it brokers trust for these chips. And then the next key thing is going out to all these companies that are building these manufacturers of MCU-based devices and explaining to them, look, here's how you need to think about security, and here's this solution that we have to offer you to help bring to you.
Looking at it right now, you've talked about what is happening in the home. Where do you see it going? We've talked about some of the other verticals. Do you see some of the other verticals really saying they want to see growth in this? Because right now, the Internet of Things we talk about is really everywhere.
It is everywhere.
And the home just seems a natural extension. Healthcare. We see so many other vertical markets really embracing manufacturing, which we talked about. Where do you see the biggest next evolution of all of this happening? happening?
Oh, well, as you say, it kind of is everywhere. We see like a huge transition in the home appliances, basically all of them becoming connected. Some immediate areas after that are like HVAC systems,
the service
security systems, the services, okay, things like that. I'll point out one of like our earliest partners on this in terms of a manufacturing partner is this company called Leone in Europe. They build cables. Okay. In fact, the first time the sales guys came and said, "Hey, we talked to these guys and they really want Azure Sphere." I said, "What do they do?" They said, "Cables." I said, "Cables, really?" And what they do is, for example, they build the cables that are used in electric car charging stations. Okay, now you're thinking about that cable. Okay, that cable carries an awful lot of electricity. You want to know that that cable is healthy so that it doesn't say share some of its electricity with you when you go to plug it into the car, for example, right? And so they do this thing where they're actually putting chips on either end of that cable so they can monitor the health of that cable. Okay, now if you step back, like imagine 15 years ago saying, "Oh, we're going to put a PC on every end of the cable."
Couldn't imagine.
You couldn't imagine that, right? That's the thing with these MCUs; they're just everywhere.
So when you look at that right now, and you look at the chips being out there, and you would you have imagined that in the kind of data we're talking about to capture in the information? How do you see that translating right now, and us being able to capture the types of information all of this is going to happen going forward?
Well, it's just huge, astronomically huge amounts of data. I mean, you think about, just imagine 9 billion devices, and let's say they're all processing, doing just preventative maintenance. The data coming up, and that's, by the way, that's 9 billion new devices every year, and those devices can have lifetimes up to 15 years. So it's like 50 billion, 100 billion devices.
And how do we extrapolate all that information? How do we process that? How do we know what's the good information from the bad information? That's the tricky part, right?
Well, let's see. Okay, so you've passed my depth of expertise. Probably what I'd say at this point is in Azure.
So it's an interesting challenge now. So now we're getting that whole new evolution of information.
Yes.
So we've come and we're saying we've got the security. Now we've got to look at all this data. So there's so many things that Microsoft is actually looking at.
Yeah, actually the correct answer is with machine learning and AI.
And that's where we're actually moving on to, right? I mean, we're really looking at this whole plethora of the change of what's happening, and it's happening so exponentially right now. I mean, that's what's so powerful when we look at all this information, right?
Absolutely.
That we never even imagined would happen like this. I mean, we always thought it was going to be in the chip that we just thought regularly in a PC, but it's not now. It's now actually in the actual device itself.
Yeah.
And when you look at that right now, what kind of devices do you think we're going to have from our homes, our cars, and we think about these kind of things that you're talking about? Where can you imagine, or what can't you imagine now is it going to be?
Well, here's one way. People ask me, well, okay, where are MCU-based devices? And here's my simple rule of thumb. If you see a device and it has a status light and a button and does not have a color LCD, it's got an MCU in it.
So that would be your difference.
And they're everywhere. I mean, in my house, I have over 100 MCU devices. I just kind of went through, walked to, just looked around everything that had a status light on it. You probably, I can guarantee you, even if you live in a one-bedroom apartment, you've got at least 25 of these devices, and your office has got them, and your car. By the way, your car has about 100 MCUs in it.
And we have them in there, and we're not even processing all of them because they're in there in advance before we even think about it.
Yeah.
And is that because it's time, as people are thinking and listening to this, is this because we're ahead of the time and we're just not actually tapping into that information? Why would we have had them and not actually taken advantage of them?
Well,
because I'm sure people are wondering why did that happen?
Okay, and by the way, these chips have existed, MCU chips.
For a long time.
Yeah, for like 40-something years. And there was Microsoft. We use this term digital transformation. Okay, the change that comes to your industry as it becomes digitized. Right. One of the things I point out to people at Microsoft is that the companies that are building devices based on MCUs, they already went through a first generation of digital transformation, and it actually happened like 20 to 40 years ago. And what happened was all of these companies that build all these everyday devices, your appliances and the motors and the valves that are in refineries and all these kind of things, they went through a transformation 20, 40 years ago when they started using MCUs. Because what an MCU was, it was a digital way of encoding programmably what used to be done, the control logic of a device, that used to be done either with mechanical, just literally, gears and thing, either mechanically or with analog circuits.
So were you just saying analog or digital is the way we made that transformation?
It all went digital. The thing is, inside the control of the devices all went digital 20 to 40 years ago, but they haven't been connected yet. And they haven't been connected because it was just too expensive to make them be connected, right? And Moore's Law, okay, we talk about Moore's Law, okay? Moore's Law it's not about physics, it's about economics. It's like, when is it economical to you adopt a new process technologies? Really a fascinating thing. These microcontrollers, okay, so like Moore's Law, Intel is right now trying to get 10 nanometer process, okay? Off of a 14 nanometer onto a 10 nanometer process. The microcontrollers, they're back at 65 and 40 nanometers. They're using process technologies that are like 15, 20 years old, okay? Because by the way, if you want to build a chip for $1, you use a depreciated fab. You don't go build the latest fab, okay? So what this means is they're still changing not very rapidly. It takes about every 4 to 6 years, but they're still changing. And so for the first time, they're basically the point where they can have radios, Wi-Fi or Bluetooth or something else, for basically free. And so, of course, they will become connected because the manufacturers see all these things, they can do it. And then all that digital transformation already happened. All that data is just going to come flooding out of those devices.
Now we see all this transformation. Now we have to think about where quantum's going to fall into all of this, right?
Well, you are going to go absolutely.
Because that's going to change it all again, right?
It is. And, that's something we're doing at Microsoft Research. We're at the leading edge of quantum computing. And it's pretty amazing, the transformation that it's going to
And we don't realize just how much that's going to change everything and what we're going to have to look at all of this, right?
Well, the fundamental thing that quantum does, I'm really probably off topic, okay, but what quantum does is it allows us to solve what are known as NP-hard problems much more efficiently than we can do with a traditional computer. And this an amazing one of the protein folding, okay, is something that quantum will allow us to do much more rapidly than we've ever been able to do with existing. In fact, if you take the entire cloud globally, you build the right kind of computer, you can do more protein folding than the entire cloud capability globally.
And that's what we're talking about. All of this digital transformation, when we talk about where actually in manufacturing we went through these revolution or Industry 4.0, we've seen this digital transformation. Now we're going to see what quantum's going to do. And all of these things that you just described are happening so quickly, faster than any time in our history. We're seeing all this. And now when you're seeing what MCUs are doing, how much more adoption do you see MCUs will take when we look at this? Because we've seen it. It's gone from analog to digital. But adoption on every little kind of device that we have, how many of them are there going to? You talked about there's a lot, but
how many of them are going to be connected?
Exactly. I mean, because we're talking about things that we have now that are not, but new devices, how are we going to actually connect those things that aren't?
It's my belief that every single MCU-based, here's the way I'll describe it. If you think about, okay, there's 9 billion of them being built a year, okay? This year, let's just round it to, 2 digits. 0 of them are connected yet, okay?
Okay.
Next year, there's going to be a few more. Next year, a few more. The year after that, more and more of those, of the new 9 billion, okay? It's my belief that within a decade, every single one of those devices that's manufactured, we go out 10 years, every single MCU-based device that's manufactured 10 years from now will be connected.
So are we talking going from billion to trillion? Are we going to see the big T word in the next couple of...
that's
a big question. That's why I think there's a lot of them.
Here's the way I'll describe it. When we talk about, I usually clump IoT into what I call greenfield and brownfield. Okay. Greenfield IoT is, the thing that no one has ever put electronics in before, and they're going to make connected. Like, think about a parking spot. 20 years ago, whoever would have thought a parking spot's going to have a computer in it, okay? But it's a pretty common thing now that they've got these sensors in,
where you park.
Okay, that's a greenfield. That's someone figured out a thing that never had electronics in it before. And figured out, if I put electronics in it, it could completely change it. One of my favorite examples of greenfield is cattle. Beef cattle, okay? If you put the right electronics on, like on a tag on a cattle, you can monitor to help that cow. You can figure out when you need to give it antibiotics, or better
the health of that cow.
Okay.
You can tell you if that cow is in, make it healthy before it fails, right?
Yeah.
Right.
Agriculture, okay, all these things, 20 years ago, you never thought, we're going to put a computer on a cow. Okay. That's greenfield.
The soil.
Yep.
Soil. Monitoring the soil. Ag, right? Preventative instead of reactive, right?
Okay. Now, when I talk about that 9 billion number per year, that's not greenfield.
Okay.
That is not new uses of microcontrollers. That is devices that already have microcontrollers that are going to become connected microcontrollers. So when you talk about, are we going to reach a trillion? Well, I guess the way we'll say it is, we're going to reach, within 10 years, we'll probably reach somewhere between 50 cumulative devices out there, between 50 and 100 billion brownfield IoT connected devices. And then, then you add on top of that all the greenfield, and could it reach a trillion? Absolutely.
And that's the amazing thing, because we're talking about doing things that right now, you even have, with FarmBeats, you even have talking about that solution where you have a farmer in Africa who's using Microsoft solutions to do things that's not only just working on a farm, but he's solving hunger, thinking about things in an entirely different way, and is connecting things that most people would never have thought of. Yeah. That's where we're going to see connected devices. So are those the things that we're going to now change, that now we're going to change lives in a different way with all of this? Is that where we're headed for?
On society.
Yeah, that's, when we think about it, that's where we have a young farmer, farming, where we think in Africa that has been around forever, and farmers over there are 64 years old, and, now you get a young farmer who says, I think I could do something different and use technology, and now that farmer says, yes, but now I can solve hunger in Africa by using a solution from Microsoft, and coming up with the kin, coming up with that solution. Are those the things that you think are going to be so revolutionary, game-changing?
Yes. It's an amazing time. It's absolutely, we have all this opportunity ahead of us.
So, Galen, we're running out of time, and I know we've got to end it up. If you could just kind of summarize for us right now, and everybody who's listening and watching, what is your greatest vision for what you've done and what you would love to see when you talk about the connected home, the MCU, where you envision the future to be? What would it be? Well,
the world I want to see come about. Okay, it is inevitable that the world is going to become connected. These MCU devices are going to be connected all over the place. I want to live in a world where they are safe, where every one of those devices has all 7 properties of a highly secured device, whether it's got Microsoft technology in it or not. I want to live in a world where every single one of those devices has all 7 properties of a highly secured device, and they're trustworthy, and I can feel safe about having them in my environment. That's the world that I want to see, and by golly, that's the world I'm going to help create.
I have to tell you, Galen Hunt, the distinguished engineer at Microsoft, I enjoyed you spending time with us today. Thank you. And I hope we see that world that you just described.
Thank you.